Alright guys, welcome back. We have question 31 and 32 from the second chapter of the mechanics of material, and these two questions are basically about the concept of true strain as opposed to engineering strain, which is what we were solving before in the channel. So let's see what we have. So let's start with the first question. Denoting the epsilon is the engineering strain in a sample that is in tension. We need to show that the true strain, which we're going to show it with epsilon t, is equal to natural log of 1 plus epsilon. So first of all, we have engineering strain where we show it with epsilon, and that would be the deformation over the initial length, or L0. And the difference in here is that for true strain, the epsilon t will be defined as the natural log of L over L0. So we need to memorize these two formula. We saw this a lot in the previous videos, but that's the formula that we have for true strain. And starting from this formula, we need to get to natural log of 1 plus epsilon. So we know that the L is L0 plus the elongation or deformation that we have. So I'm just going to rewrite that. Our epsilon t would be natural log of L. I'm just going to put this L0 plus delta over L0, and we just have to divide each of these by L0, which means we have Ln1 plus delta over L0, and that would be our epsilon. So basically our epsilon t would be Ln1 plus epsilon, which is what the question is asking us to show, and that would be the answer for the question 31. And let's move on to the question 32. So in this one, we know the volume of tensile specimen is essentially constant while plastic deformation occurs, and we know the initial diameter of the specimen is d1, and we need to show that when the diameter is d, the true strain again is 2ln of d1 over d. So one thing that we have to consider in here, we're going to have a cylindrical specimen where we have the diameter and this is constant. So if we just call the diameter that we have in here d1, and let's just consider the length of L, we know the volume would be, this is actually the diameter, it's not the radius, d1. So we're going to have pi over 4d squared times L, which is basically the area times the length, which would be the volume of a cylinder. And we have two different variables in here. The diameter is basically changing and our length would be accordingly changing too. So it's going to turn to something like this, which is called this one L0. It's going to turn to D, and we're going to have the length of L. So the volume of these two are the same. So for the first one, we're going to have pi over 4 d1 squared times L0, and this has to be equal to pi over 4 d squared times L. So we can cancel these, and I'm just going to bring the length on one side of the equation and the diameter on the other side. So if we just divide this by L0 times d squared on the left side, we're going to have d1 over d squared, d1 squared over d squared, and on the right side we basically have L over L0. And we know this part can be written as d1 over d all to the power of 2. So that's what we get so far from here, and we figured that our total strain is from the formula that we just discussed, so natural log of L over L0. So this would be basically, if we just put what we had in the previous step, natural log of d1 over d all to the power of 2. From the laws of the logarithm, we know this can go in the back, so the epsilon t, or true strain, would be 2ln of d1 over d. And if we get back to the question, that's what we had in here. And yeah, that's one answer for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.